In Roshan's early open science days, she wrote a registered report that was ultimately rejected. But in this talk, she will provide hindsight into rookie mistakes that she made and hopefully help you to avoid them. Her talk is called Registered Reports, the gold standard of open research is also the most challenging to do. Welcome, Roshan, and over to you.
Hi, thank you very much. Can you see me?
Yes, you can.
Okay, great. So before I go into the challenges of registered reports, I wanted to first give a brief introduction about where registered reports come from and also the difference between registered reports and pre-registrations, because we hear these terms a lot and some people use them interchangeably, but they're actually quite different. So hopefully this will just serve as sort of a primer for you, and then I'll go into the challenges of registered reports. So first, a short history of why we even have registered reports and pre-registrations. So it all goes back to the scientific method. And we all know that we are supposed to follow this very linear scientific method. That's really all it takes to be a scientist. In the registered report that I submitted, I followed the scientific method pretty perfectly. You're kind of forced to follow the scientific method in a registered report. First, what I did was I made the observation that the cortical representation of faces is distributed across the brain rather than localized to a particular area. But previous studies have been kind of back and forth on this. Some say that the fusiform face area is a very selective brain area for the representation of faces, whereas other studies say that it's distributed all over the place, oftentimes in object selective areas. So my question was, why does it seem that face representation is so distributed in some studies and so localized in others? And my hypothesis was that faces as a category are represented in object selective cortex, otherwise called OSC, but specific face identity would be represented in the fusiform face area. Fusiform face area has also been known to activate for objects of expertise, so I thought I might be able to find a difference there. So I came up with an experiment. I wanted to test whether there are representational differences for face identity versus faces as a category and compare patterns of activity to object representations in the brain. And I wanted to do this fancy method called MVPA. It's just this method of finding out different patterns of activity in small parts of the brain rather than large regions of the brain. So it is a different kind of analysis than what's typically done. And then I wanted to just determine if there was evidence in favor or against my hypothesis. So we don't always conduct science in such a linear way. I had to think very linearly in order to submit a registered report. Usually the way that science goes, and Alexis did touch on this, is that people tend to use a sort of scientific method where sometimes you just have a cool idea for an experiment and it's not based on any observation. You just think it would be fun to try out and see what happens. But I wonder what would happen is not really a question. And it definitely doesn't lead to any clear or directed hypotheses. So you often end up running a cool experiment, trying out a bunch of different conditions. Then you're left with a lot of data. You don't know really what to expect. You didn't expect anything. So you discuss the data with your collaborators, analyze using various methods, maybe a different technique or a tool, and eventually something will come out. Usually, especially with multivariate data, something will come out. Then you can write your story around that, come up with a nice little publication, and that's called harking, as Alexis pointed out in his talk. The problem with this is that it will probably never replicate, also as discussed, because it was an exploratory study published as a confirmatory study. And this is the kind of science that has led to the replication crisis. And it was officially brought to attention to the public in 2005. And it's still a huge problem to this day. And the number of studies that don't replicate could be about as high as 50%. So we're really trying to get that number down. However, we're not doomed. In 2013, Chris Chambers came up with the registered report format, which began at the journal Cortex. It quickly spread to other journals, and you can find a list of all the journals that accept registered reports now, over 300 of them, according to the Center of Open Science. But it's not all sunshine and rainbows, as you will see. There are a lot of challenges involved in pre-registrations and registered reports. So let's get serious and discuss pre-registration and registered reports, what they are. Then you can decide for yourself whether registered reports are for you. So the difference between pre-registration and registered reports, basically a pre-registration is what you would submit to an ethics committee prior to running a new study. You have a couple paragraphs of background. You usually give your hypotheses, questions, study design, and you just throw that up on a website like the Open Science Framework. Once that's submitted, it's permanently available to view. You can't edit or delete it. You don't have to follow it exactly once you've put it up on the website. You're not pressured to do that study, but it has to be there and it stays there so people can just take a look at what you had planned to do. Registered reports, on the other hand, are a fully polished manuscript with introduction, methods, analysis plan. You have pilot data. So you run your full analysis plan with 5 to 10 pilot subjects, run a power analysis, and at stage 1, that's when you submit the registered report the first time. It's missing the main results and discussion because you haven't collected your main data yet. After it's accepted at stage 1, then you can go ahead and run your study. Then the acceptance to full publication is streamlined at stage 2. So just to give you an example, I'm going to show you a pre-registration. It's not mine. It's just one of the many open access pre-registrations that's available on the Open Science Framework. So you usually start with some study information. You have descriptive information, so just a couple paragraphs, not a full introduction section. You have to have research questions, hypotheses listed. You have your design plan. What is the study design? Is there any randomization? How are you going to collect your data? How will you determine your sample size? What are your independent and dependent variables? You have to be pretty explicit with this. What is your analysis plan, including statistical models? Are you going to make any transformations on your data exclusions, etc.? And this, like I said, will just stay online forever. You don't have to follow it, but people can always refer to it. And you can link it to a study, even if you don't follow it exactly. A registered report, on the other hand, I'm going to show you my registered report that I submitted at stage 1, is basically 3/5 of an actual manuscript. You have your letter to the editor, you have your fancy title page, abstract, introduction, like a regular 5-page introduction, materials and methods, power analyses, stimuli, even nice figures. They want you to have fully polished figures at stage 1 submission before you even run your study. And you have to give all of the details that you would in a typical study, all the way up to the results section, including references. So that's the difference between a pre-registration and a registered report. So what is available before publication? Compared to a typical manuscript, which provides no information prior to publication, pre-registrations will give you a look at what the initial question, hypothesis, design, and analysis plan was, even if it's not what the researchers end up doing. And registered reports lay out exactly what will be done, and this cannot have any deviations with very exceptional circumstances, and you have to include pilot data and power analyses. So what's the rewarding part of registered reports? So what's great about it is that even though it takes a long time to get through stage 1, because you have to design your whole study and think of your whole study before you can even run it, the stage 2 process, so that is collecting your data, analysis, and writing up your results and discussion, and then publication, all of that can happen in just a couple of months. Also, what's really nice is reviewers can't reject at stage 2 based on how your results come out. So even if you get null results, the reviewers have to accept it as it was if you followed the analysis plan that you put up in stage 1. And it's also lauded by high-ranking journals like Cortex and Nature Human Behavior if you want to get into one of those journals. But of course, probably the best thing about registered reports is they make you a better scientist because they force you to follow the scientific method. The hard part about registered reports is that you must stick to the stated methods and analyses. This can be very time-consuming and challenging to think ahead, whereas pre-registrations can deviate substantially from the methods and analysis that you put forth. Registered reports have to adhere very strictly to this. You also must include directly relevant power analyses above a conservative threshold. Cortex and Nature Human Behavior both want 90% power. So some journals ask for 80% power. Higher level journals ask for 90% power, and as you may or may not know, in psychological experiments, it's often very difficult to get to reach that power threshold. So your study can just be thrown out if it doesn't reach that high conservative threshold at the pilot phase. You also can't recycle pilot subjects from somewhat related studies, which was an issue that I ran into, and I'll tell you about that in a moment. And after all of this, the results may not come out the way you want them to. For some people, that might not be a big deal, but for other people, their dreams might be crushed. But at least you're doing good science, right? One major issue is that some scientists actively resist the reproducibility movement, and they consider registered reports and those who write them a threat, which can be very difficult for young scientists, for those who don't have tenure, for PhD students. All of these practices can be very hard to do at an early stage in your career. So now I'm going to take you through my personal experience with registered report rejection and how it came about. So as I mentioned before, it is important to state clearly what kind of analysis you want to perform and also state specific conditions of interest. So first, the goal was to conduct a classification analysis using a very specific type of MRI analysis on face identity versus categorical representation of faces. But I didn't have classification data at the time that I was running this, and I still don't really know how to perform power analyses on classification data. There's no available toolbox for that. So the power analysis was based on what's called univariate bold data, which is just a different type of analysis. Also, the data I had from a previous study was based on animal identity versus category, not faces. So it's not exactly the same type of information that I was looking into. My targeted regions of interest were fusiform face area and object selective cortex, but for some reason, I think because I wanted to leave my options open to do whole brain and exploratory analyses, I actually ended up doing power analyses in a bunch of different regions that were not the regions of interest. I don't know what I was thinking. Not to mention all of the power hovered between 56 and 88%, so it did not reach that 90% threshold that was required of the journal. Finally, I estimated a need for 20 subjects with 96 trials each, but my power analyses were estimated for 22 subjects with 72 trials per condition, just because it was based on pilot data that was not so heavily related to the study that I was proposing. So in conclusion, the power analysis mistakes that I made, I performed them on different kinds of data. I performed them for irrelevant stimuli and irrelevant regions of interest. But the main issue was that the power was just not high enough to be accepted by the journal cortex. Why did I make these mistakes? Well, at the time that I submitted my first registered report as an early postdoc, the format had not been around for very long. I didn't know anyone who had submitted a registered report before, and neither did my boss. So I just kind of blundered my way through, and I made a lot of mistakes because I thought that the journal would go kind of easy on me. I thought that, first of all, main analyses could sort of be inspired by pilot data, like how you would usually motivate a new study with related research. It's also hard to get out of the exploratory mindset. I wanted to keep myself open for whole brain exploratory analyses, not just restrict myself to 2 regions of interest. And I was kind of worried, what if I missed something interesting? And so in general, I underestimated the rigidity of the submission criteria because really when you're submitting a registered report, these people don't mess around. They don't make exceptions, and the format is incredibly strict and has a lot of requirements to ensure that the data are high quality and that high quality research is being done. So I hope that this was informative and that you can avoid the mistakes that I've made. So thank you very much for listening, and you can find more information on my website. Thank you very much.